Hi everyone, in this video I'm going to show the training process of a self-built neural network AI. And so basically the background of this project is it originates from a project that I've built last year summer, which involves a monitor system. That project uses a Raspberry Pi 4B to capture videos of scenes in like a short amount of time. So basically it captures a photo every 10 seconds, and this can last for several days, which gives me like about 10,000 photos of a fixed place. And during the winter I captured about 10,000 photos of the street in front of my house, and I decided to use these photos to train a picture recognizing AI that recognize whether there's a car or not in the picture. So now here it shows this the training process of this AI. The the basic working principle of neural network I'll explain in my article that I will publish uh, later. But now I'm just going to briefly introduce its working principle. So basically, a neural network is just a network that maps like a input, for example, a image to a output, like a value in this case. So this neural network, for example, it takes a image as an input and outputs a value, which is the possibility that there's a car in this image. And there are parameters in this neural network. And at the very start of this training process, the parameters are set as random. And so when the training begins, the program will randomly generate a few AI models that have randomly set parameters. And they will run all of these randomly generated models through those testing cases and calculate the sum of error of their result compared to the literacy value. And then the program will pick this AI model with the smallest error and save the model. And in the next round, the program will read the model from a file and then make small adjustments to those parameters, and then generating a few other AI models that is pretty similar to the previous one but has small changes made to its parameters. And then the program will repeat this process, um, taking all of those AI models through the testing cases and pick the one with the smallest error and then make small changes to its parameters and repeat. And after several rounds of this process, the overall sum of error of the AI model will decrease. And finally, hopefully, we'll get an AI model that is relatively accurate. And now I'll introduce you to my testing cases. So as you can see in this folder, the folder named 0 and 1 are the testing cases. In the folder 0 is basically images without cars in them. So as you can see, there's no cars in these images. And in the folder that names 1, there's images that has a car in them. So as you can see, these images have cars in them. And here I also leave about 1,000 photos for testing purposes. So after I've trained the model, I can use those 1,000 photos to test whether my model is accurate or not. And now here comes the training process. So this window shows the training information of the first generation of the model. As you can see, for the first randomly generated model, it has an overall sum of error of 1,777.99, which is like pretty high considering that we only have about 3,000 testing photos. And then it made small adjustments to the randomly generated model, and then he run all of those models through the testing cases and then found the smallest one, which has a overall sum of error of 1,777.98, which is smaller than the previous one. So the program takes the smallest model and then recorded it in this file, as you can see here, and then the program ends. After the program ends, it will restart itself, and then the restarted program will read again from this file the currently most accurate model, and then it goes into this black window. So it reads the current model and then tests its sum of error and then makes small adjustments to this model, runs it through all of the testing data again and found the smallest one. If the smallest one is not the smallest currently compared to the previous smallest one, then it will continue this process, making small adjustments, running through all the testing cases and find the smallest one. As long as he has found a AI model that has a smaller error than the currently smallest one, then this program will end and the program will record the smallest AI model into the file and it restarts itself and the process repeats. So this is basically how my AI is working, and hopefully I can generate a relatively accurate AI model using this simple algorithm. So see you next time.